Have you ever wondered how we measure things so accurately? So in this video, let's understand units and measurement in a simple way. Imagine two people measuring the same table using different methods. One person uses hand spans while another uses a ruler. Both get different answers. This creates confusion. That's why we need standard measurements that everyone can use and understand. In physics, anything that can be measured is called a physical quantity. For example, the length of a pencil, the mass of an apple, temperature, speed, and time are all physical quantities. If we can measure it, then it is a physical quantity. Every measurement has two parts, a number and a unit. For example, in 5 meters, 2 kilograms, 10 seconds. 5 is the numerical value and meter is the unit. Units help us understand exactly what is being measured. Physical quantities are mainly divided into two types: fundamental quantities and derived quantities. Fundamental quantities are basic quantities, while derived quantities are formed using them. Fundamental quantities are independent quantities. They do not depend on any other quantity. Examples include length, mass, time, temperature, and electric current. Their units are called fundamental units. To make measurements uniform across the world, scientists developed the SI system of units. SI stands for International System of Units. Today, it is the standard system used worldwide in science and engineering. The SI system contains 7 base units. For example, meter is used for length, kilogram for mass, second for time, Kelvin for temperature, ampere for electric current, mole for amount of substance, and candela for luminous intensity. These base units form the foundation of all other units. Derived quantities are created by combining fundamental quantities. For example, speed is distance divided by time, force is mass multiplied by acceleration, and area is length multiplied by breadth. So derived quantities depend on fundamental quantities. We use different instruments to measure different quantities. A ruler measures length. Precise instruments like vernier calipers measure very small distances accurately, and a screw gauge measures the thickness or diameter of very tiny objects like wires. Now let's understand the difference between accuracy and precision. Look at these targets carefully. Accuracy means how close the measurement is to the true value or the center of the target. Precision means getting almost the same result repeatedly, even if it is not close to the center. And when the measurements are both close to the center and closely grouped together, they are both accurate and precise. Sometimes in science, numbers become very large and difficult to write, so scientists use scientific notation to write them in a shorter form. For example, in this number, we move the decimal point 8 places to the left, so 300 million can be written as 3 into 10 raised to the power 8. This makes calculations much easier and faster. Units and measurements are used everywhere in our daily life. Doctors measure temperature, engineers measure structures, scientists perform experiments, and athletes measure time and speed. Without measurement, modern science and technology would not be possible. So today we learned about unit, physical quantities, fundamental and derived quantities, SI units, and measurement concepts. These are the basic foundation of physics. Understanding them clearly will help you learn many advanced physics topics in the future.